Hi dear viewers, in this video we are going to discuss about solenoid and relays. So in the mechatronics subject module 4 we are discussing about actuation systems. That is one is electrical actuation systems. In this electrical actuation system, previous video we have seen what is a drive, what is how a drive system is going to help in industries, CNC machines or some other machines, how the drive is going to be function. That's in the previous videos we have seen. And now next video, in this video we are going to see about the solenoids and relays. So what is a solenoid and what is a relay? Okay, these are the different solenoids which are used in the industries. You can see this left side is a solenoid which is given, and right side whatever it is the relays. Okay, how it is going to be function, let me see in depth inside in this video. So solenoid, what do you mean by a solenoid? Solenoid is a device which is composed of a coil and with a movable plunger. Okay, in the previous mechanical and measurements labs, you might have studied about the linear variable differential transducers, right? In that, we are moving the plunger inside a magnetic coil, inside a coil, primary coil and secondary coil. We are going to produce a magnetic field like that. EMF is going to be produced like that. We might have studied in that LVDT. Here, a solenoid is just like the a plunger is there, and over to the plunger a coil is wounded up. Now we know that the law of conduction of electricity, in that where we are conducting electrical current through the coil, current carrying coil. When there is a magnetic field is going to be produced, and the magnetic field may pull or push the plunger inside. This is how the function of solenoid is going to take place. When electrical supply is given, the magnetic field is going to be produced so that the plunger moves in. That is a mechanical electrical energy is converted into mechanical energy over here. You can see the construction of the solenoid here. So in the left side we show the linear solenoid. So in the linear solenoid, a magnetic flux lines are there. This is the plunger which is having a coil. Like when electrical supply is given, magnetic flux created, and then it push this or pull the plunger, so that it is the movement over here. And it is used in the industries. For example, we will say this: it is used for valve opening closing. Okay, when there is a valve to be opened or valve to be closed in a pipeline, plunger with the valve seat is there, and when power supply is given to the coil, automatically this electrical a current magnetic field is getting produced, and the plunger is pushed upwards so that it will allow the liquid to flow, or it may push it down to close this valve. That is what it depends upon the normally open condition or normally closed condition switches, how it is available. Normally open condition in the sense, always it is open. Only if you activate, if you give the supply, it will going to close it. Normally closed switch in the sense, it is always it is closed condition, and if you give a supply, it will become open. So this is, let me see in the next relays also how it is going to be function. So this is how a solenoid is going to be work. So solenoid is a device which comprises of the coil and with the movable plunger inside. Okay, now let me see a relay. What is a relay? Relay is just an electrically operated switch. Okay, it consists of the input terminals for a single or multiple control signals, and a set of contact terminals. Just like our switches, we call it as, that is the switches or the relays. Here now contacts will be there. So when contacts is going to be get connected, the circuit is going to be closed, and if disconnected, the circuit is disconnected. So here also, just like normal open, normal closed condition relay switches will there. So in this figure we can see the normally closed condition. So when we are giving a electrical supply, the magnetic field is going to be produced, and it is going to be open. Okay, it will help to open the circuit. You can see now, I'll tell, since it is normally closed. Okay, it's a normally closed circuit. You can see this is get closed over here, and when here what is energizing coil with a coil is there. When we are supplying the coil, and the here what will happen, magnetic field is produced in the coil. So the magnetic field which is produced is going to pull the magnet, here magnet which is attached here. Automatically the ion gets connected, then the movement of the armature towards this left side, and here due to the pivot movement it will move upward. In this end, the end is going to move upward. So what will happen if it moves upward? So already it is in contact, it is in contact here, so that when it moves upward, it pushes the contact and it breaks the contact. Okay, so that is a movable contact, and remaining are fixed contacts. So movable contact, this is a movable contact, it is going to be moved upward. When the pivot is acting this direction, it pushes this. So this is how normally closed relay switch is going to be function. And normally open in the sense automatically the reverse what it is there. So normally closed, normally open, two different types of switches available. So in normally open switches, the contacts is already getting the contacts are closed only when we are applying electrical energy, and until that it is open condition only. In normally closed position, the contacts are in a closed position. If you switch on, then it is going to be open. So this is the logic of the normally open and closed circuits. So what will happen, the closed or opened circuits, it's mainly used for making or breaking the contacts. So making and contact, because of the electrical relay coil is energized or de-energized, normally which is since it is in a position, if you're switching on it, then the position is going to be changed, and if it is that is de-energized, it comes to the normal position, original position. So that is called normally closed or normally open. So where no supply will be given, then at the time how it will be there. One more relay diagram is here also. You can see this. When the electrical supply is given, the electromagnetic, it pushes the, and it pulls this movable arm armature, so that it makes a contact at this top. Then a circuit is going to be closed. When it is switched on, due to the spring action, okay, so here we can see a spring action here. So when it is deactivated, this spring, it will move upward the contact, so that it is the contact is getting break. So by using the spring and electromagnets actions of energizing and de-energizing, this relay is going to be function. Okay, this is what about function of the relays, how it is working. Okay, in the next video where we will see about other topics, that is DC motors and all. Okay, thank you very much.